All right, welcome back. So last week was review, but this week is some new content. So this week is data structures. Next week, to read a little bit ahead on this, we're going to be going into a little bit of software design and ideal or suggested software patterns for like how you might lay out an application to make it easier to work with. But today we're going to be covering data structures. And this is kind of where we get a little bit more into the theoretical side, but it's, for the most part, we're going to stick with data structures that you are likely to actually use in like an application. So we're not really going to touch on something like binary trees. For anyone who knows what that is, I'm sorry, we're not touching that on this, but we're going to touch on things like maps and the like on today. So yeah. So I guess to start with this, right? So structured data. So by data structures, we're referring to a way in order to actually store the data of our program, right? Like, for example, I know that the following, where's my marker? Okay. So it's like, for example, like I know when I'm writing that I'm going to have the following pieces of data, right? And I know they're going to have the following corresponding values, right? Okay. What I could do is I could set these all to be individual variables, and that will technically work, but it's going to be pretty hard to follow after a while. And if you get to a point where you're like, oh, what if I want to dynamically create this piece of information? What if I want to dynamically store this piece of information, right? Like, let's say I have a database and I have some users, right? I can't make a variable for each user in the database. That doesn't exactly make any sense. So we could use something like a data structure in order to properly store and represent this information. So that's what we're referring to today. Okay, also, I love this photo. Cats just fit everywhere. But anyways, so what's a data structure? I guess the best way to phrase it is it's just a method or a way to organize the data that we have, right? So, and there are strengths and weaknesses to the various approaches we can take, right? So like for example, some data structures are going to have significantly easier times for you to actually access it. They're also going to have significantly faster times. Some will have significantly faster times to update the data that's currently stored in them. So there are different solutions to different methods of data or types of data that you will want to store, right? So it's partially, and that's something we kind of do touch on here, is like we do get a little bit into when would I want to use one data structure over another, right? And obviously this is not an inclusive list, and there's nothing stopping you from building out your own or building things that are hybrids of these. Have done that personally, but it's just a short high-level explanation of some very common ones. Okay. And of course, the obligatory disclaimer on this, because this is going to be a fairly opinionated piece, there are a lot of different data structures available. And some are better than others, right? So there's a working solution to every problem, and there's an efficient solution to every problem. I love that statement. So what this is referring to is saying some of these data structures will accomplish the job. They may not be the most efficient. They may not be the fastest. They may not be the cleanest. Like, for example, there is nothing stopping you from loading an entire database into a list. You probably shouldn't, but there's nothing stopping you from doing it, besides maybe your own computer memory. But that's not exactly the most efficient solution to the problem, right? But all that being said, a very important note as we go through this is to keep in mind that you should always be focused on making your code work in the first place, and then you can go back and deal with efficiency and the details of that, right? Like, if it's already running fast enough to accomplish the goal and what you need to, you probably don't need to spend 2 days trying to optimize how can you trim off, I don't know, 6 kilobytes of memory. Not really necessary in most cases. Okay, so here's a common data structure, and this is the one that we've used pretty much up until this point in class. This is a list, which we will commonly refer, which is also referred to as an array in a good chunk of the programming world. So, what is this? Well, A list or an array is the data structure that's going to store whatever items you give it in a, okay, let me go back. Let me go to the next slide. Probably be a better way to explain this. So basically, it's a way to store them in order, right? So sequential. So this is nice, right? So like, for example, if I give it 1, 2, 3, 4, 5, 6, and I access the item at index 0, which due to the way programming works in most C-based languages is actually going to reference this first value here. And 1 is going to be here, 2 is going to be here, 3 is going to be here, 4, 5. I say most. There are some languages that do not do that. I believe Pascal is one of them, and some languages that take inspiration from it, such as Lua. Those languages will actually start at 1. But for the vast majority of them, they start at 0. But yeah. So why would I use an array? Why would I use a list? Well, accessing it's fast. If I know exactly where in this series of data or this structure I want to access a piece of data, I can simply just be like, okay, list 1, I would like to access element 0. Okay, that's going to print 1. Or for list 2, I would like to access what is at index 3 of the data structure. And that's going to print D in this case. And of course, in Python, indexes start from 0. That's the case for most languages, but there are always exceptions to every rule in programming. Okay. And relatively speaking, the index, which is how we're actually referring to it down here, is the spot in the list, right? So 0 for the beginning, and middle would be 0, 1, 2. 2 or 3 would be the middle and the top one for the index. But yeah. And of course, within this list, they're going to be ordered, right? They're going to be in the order that they were provided. So they're not going to randomly change around here unless you call something like a sort function, which we did do a little bit on a worksheet / workshop. So if you're curious how that works, advice taking a look at it. But yeah. Do we have any questions on this topic, on this area? Because I believe, and then we've already kind of gone through that topic right there. But yeah, do we have any topic, do we have any questions on this so far? All right. So, all right, so another benefit of the list. It's very fast and it's easy to expand, right? So, if I want to add an item to a list, I just do append. Piece of cake, right? So I would just do names.append here, names being the name of our list, and all 10 blahi, or append blahi to the list here. Cool. And then I will append the evil witch Raza to it. And if I want to remove a value, I just call .pop, and .pop is going to remove the last item. This also brings in another important note, right? A list is very easy to add items to, specifically to the end, or to remove items from, specifically at the end. And it's also very fast to do it this way. You could technically remove it from the middle, but that's going to actually be very computationally expensive. And what I mean is, if we go back to this previous one, in order to do this, you're effectively going to have to, you would have to remove this and then shift all of these over. At a high level explanation, there's more going on under the hood in terms of how Python handles it, or every language handles this. But in general, it's significantly slower if you are shortening or removing an item from a list if you are not removing from the end of the list. Also relatively slow to search. So if I want to search in the list, I have to go through the list, and I'm going to have to go through every single item in it. Which if you have, say, 2 million, 3 million items in a list, which is completely possible, you might end up in a situation where that really doesn't work for you. So, okay. Now, on another note, because of the nature of this, if you remove an item from a list, it's also going to be much slower as well, right? It's fast to remove from the end, but if you remove the item from the list and it is at the middle or the beginning, it's going to be a lot slower. Memory serves, I believe this is because you have to actually recreate the list in Python's case, but someone can correct me if I'm wrong on that. Now, I should probably explain what these two functions do, or what this function does. .remove removes the item from the list. So this would, in this case, remove Apple from the list. I can also completely delete it if I choose to, doing a similar thought where I do del names 0. And I will delete whatever is at index 0 here. In terms of practical impact to your program, this is going to be roughly the same impact. There's a slight difference in terms of implementation on the runtime from Python side. But yeah, this is like an example of how you would remove some data from here. All right. And a fun thing about Python, right? In some, and for context, in some languages, this is referred to as a substring. So, if we wanted to, or if you were working with, say, if this were a string, like the best way I can bring this in a comparison to other languages is in some languages, in a lot of languages actually, you have an option to do something similar to this if you're trying to get for like strings and the like. Python makes this very easy for arrays as well. So, for example, if I want to say get the items between two indexes, so let's say I want to get shield and potion. Okay. Then I want to drop index 0, index 1. I want to include 2 and 3, but I also want to drop 4. So, for context on this, this is going to go from the index you provide up to that point. So, 0, 1, 2. Okay, now we're at 2. Now we can start including this. 3, 4. And to clarify, up to but not including. Slicing in Python's fun. It's very fast. And they make it very trivial to be like, I just want this part of the list. There's a lot of things you can do with this. So you can be like, okay, I want to start from index 0. I want to start from, so you want to start from index 0. You don't actually even have to specify the number here. But yeah. Python definitely makes this a lot easier than a number of other languages. Yeah. All right. So that is the data structure that we have primarily been using up to this point. And arguably, I would say it's one of the most common, if not the most common data structure you would work with whenever you are actively programming an application. Another example of something that, and this is, I admit, used a bit less, quite a bit less, is because a list will allow you to store effectively whatever you want to in it. You can effectively make a list contain lists. If this sounds like it could be a little bit difficult to figure out what is going on, you are correct. But if you were wanting to represent something like a map for an RPG, or you were wanting to represent something like a chessboard or a checkerboard, or something where you can very clearly distinguish where each item is going to be, and you want to logically map that back. Speaking from experience, I've actually used this I've used this same data structure for writing like rendering engines for like games that are 2D based with sprites, where I would have like each individual spot in here going down from left to right, rendering across the screen. It's a really good representation of that. So if I were to print board 1, so the way this works is you're going to access the value of the first. You're going to access the value of the first list, right? Okay. This is going to be 0, 1 in this case. Okay. So we are on this list here with the 1 index. Okay. Now we're going to go 0, 1, 2. And there we go. Looks like this will print apple. Now, as to why there's an enemy right next to me, I don't know anymore. But, yeah, that is effectively how this will work. It's a very powerful data structure given the correct use case. It's a very bad data structure in the wrong use case. One that I honestly have used a lot more, and probably something I've used probably more than I should, is hash maps or dictionaries. And these are fun. So the logic of a hash map or dictionary in this case is you have a key, which is what you were defining how you were storing it. And then you're going to have a value, right? And Python internally is going to go through this hashing function that determines how it's going to be stored, right? Okay, cool. The cool thing about this is if you define something in a hash map and you say it is of name blank, you can literally just access it with that key in the future. And we'll show how to do that later in this lesson. But yeah. And you can represent just about anything here if you choose to as a value. There are some nuances on representing things like objects as values, but there are ways to represent just about everything. Now, and of course there's a note here at the bottom that said, doesn't this look kind of like a list? And the answer is, yeah, a little bit, right? So effectively, if you would like to view it that way, you are, instead of accessing something by an index, you're accessing it by a key. And this is probably worth mentioning that while this is typically very fast, if you pass in certain things, such as objects into here, it is going to be very, very slow because of the hashing function itself. It's going to have to process that entire object. You could do it. Would recommend you don't from a pure performance perspective. But yeah, in case of a hash map, it is very fast in order to access something. So let's say, for example, I want to define how a dictionary is set up here. Okay, so I have birthdays set here, and I have two keys set. Key for Apple, key for Lucia. You have Apple's info here, and you have mine, and I'm not going to state that. But so let's say if I want to search and see if the key Lucia is in the dictionary. And this is very useful because you can actually go through, like, let's say you received a piece of data from a network request or an API. This would, let's say you're writing a web application. This would allow you to see, yes, okay, the user did in fact provide this key. I can do something with this information. In this case, because Lucia, the key is set, it's going to go through and it's going to print secret. And I can also add another key if I wish to. So for example, if I define that as the name of the dictionary with the name of the key, in this case, Blahai, we can say the birthday is October 13th. Okay. And if we want to remove key from the dictionary, we can just do delete and the dictionary and the key name, and that will remove the value and the key. So fun thing about this, adding this in due to the way the hashing function is implemented, let me go back to this previous slide. Because the way this is implemented, where you're effectively just dropping these values in here, doesn't really matter what order they are back here. This is going to be a lot faster if you wanted to just insert something regardless of the context or index, right? Because keep in mind, like if we had a list, right, and I wanted to remove a value from the list, and I wanted to remove it from the middle, it's going to be very slow. The key value pair, that is not going to be the case. If I want to add something, likewise, it's going to be a lot faster. Because all it's literally doing is it's going to take the key, it's going to take the value, it's going to run them through the hashing function here, and then it's going to store the value, and you can reference it by the key. It's a very nice way in order to represent data in your application. All right. So let's jump on here real quick. And this is a very important one here to note. And some languages may have notes on how they implement this, but I really have to emphasize this detail here. And I'm emphasizing this because I have literally had a bug that has taken 6 hours of my life to debug because I forgot about this. So some languages, they will be in order. That's awesome. In general, you really shouldn't depend on it. They're not guaranteed to have order. If you need to have order, use a list in this scenario. But if you want to read, so effectively, if you were to iterate over / read the entire dictionary, you're not guaranteed across all languages to have the exact same order. Now, I am saying this with the ampersand / note of depending on the language, because there are languages that do enforce this. But considering we're more teaching general programming concepts, that's a general rule of thumb on it. Also, for anyone who wants an example of where that bug came from, it was bash. Bash does not keep them in order. And that is how I very painfully learned that lesson. But yeah. Do we have any questions on hash maps up to this point?
We have one question from the Discord.
Absolutely. What do we got?
Which is just, so would this mostly work with integers and strings?
That would be the ideal use. That would be the ideal use case for it. You could technically store an entire object as a value if you wanted to. There's not really anything going to stop you. It's just going to have to go through and hash the entire object, which is really going to hurt the efficiency of it. But completely honestly here, I have done that myself before, and it is, while it is not very performant, if it's not a huge amount of data anyways, it's probably not going to really impact the situation. In that scenario, I chose to take the performance hit because I felt it would make the code a lot cleaner and easier to read. But that was a intentional decision in that regard. But yeah, that is correct. It would be better for things like integers and strings, or even booleans to represent this information. Really good question though. Go for it. Great question. So you don't have to delete it. We're only deleting it here as an example to show how you would remove the information. In a lot of cases, you don't want to remove the information at all. So, like, you don't have to remove this. And yeah, like most of the time you don't want to. I guess another note on here that's kind of worth mentioning is in the case of this, like in the case of a dictionary, you can overwrite the existing key. So like, for example, if I were to assign a value to the key Lucia, you could change the value of it. But yeah, no, you don't have to delete it. It's more of a, for the purposes of example here, we're showing how to do so. Hopefully that answers your question. Excellent. Cool. Do we have any other questions in the Discord or the Twitch stream?
Nothing so far.
Excellent. My tracking just broke, and I wonder if it caught on the camera. All right, let's jump to. I guess let's jump to sets. This is going to be a fun one to do some explaining on. Also, I guess one note on this. If you want a really concrete example of this, if you were, say, wanting to store a configuration file and you wanted that configuration file to then contain easily readable values, you could actually send everything to a hash map, write it as something like JSON, read it back, and bring it back to a map, and then you have all your keys and values available. An example of why this is such a powerful data structure. All right, I'm going to go to sets because, yeah, probably a good idea to include information, all of them, right? Okay, so what is a set? Well, the idea of a set is it is a collection of unordered items, and there's no duplicates in it. So if I add the same item twice, then it simply does not add. Like if I attempt to, it's not going to happen. So, like for example, if I attempt to add cat twice, I'm only going to have one cat in this data structure. In terms of, oh yeah, also it acts very similar in terms of a hash map in that it's going to hash the value and it's going to store it as a key value pair. But yeah, so that's effectively how that one works. In terms of speed, you want to check to see if a value exists. It's very quick. If you want to delete a value, it's also very fast. Keeping in mind, yeah, order is not exactly too important here. So because we don't have to keep the order, we can delete it a lot faster. Because unfortunately, when you do deletions, you have to actually consider things like what is the new order of the items, which means you have to rearrange it, which is much slower. All right. And there are a lot more data structures that are usable here. And there are also implementations, which may be fun for some individuals. But yeah, to give a couple data structures we did not cover that that might be kind of fun. There's a queue, a stack, or a tree. And trees are their own thing altogether, and we could genuinely spend the entire lesson here explaining what a tree is. But so I'm going to leave that as for anyone who wants to read into this more. As for queues, the idea is, let's see. Let me see if I've got this terminology correct. First in, first out. So if you were to add an item, it will be the first. If you were to add an item, it is going to be the. If you add an item first, it will be the first item you remove. In terms of a stack, and fun little bit of trivia for you, some older programming languages. In fact, I think actually the original version of Pac-Man, believe it or not, was actually written in a language that heavily utilized this. But the idea of a stack is that if you add an item to the data structure, the first item you add is actually going to be the last item you remove if you go down and start removing items off of it, which is useful in some situations, but yeah, giving it as an example here. And have to emphasize this. important not to stress over a perfect solution. By all means, go for a working solution. Like, for example, we used a 2D array or a list of lists here as an example for a map. It is also commonly implemented as a tree. So, using it as an example of doesn't have to be perfect. There are multiple ways to implement this. Important not to spend all your time trying to come up with the perfect solution. Okay. Do we have any questions on this? Awesome. Wow. Is that the...
nothing yet.
Okay.
Though I suppose I have one question.
Go for it.
With dictionaries, what happens if you in Python if we use the square brackets way of getting the value out of the dictionary? What happens if the value isn't in the dictionary?
That is a great question, and I have to actually double check the documentation on that because I am actually forgetting off the top of my head if it is a exception or if the value is none. I believe the value is none, but I want to double check that.
I thought it was an exception.
I wasn't 100% sure. That's kind of what... I know some languages treat it as null or an undefined value. I think the other thing is I personally tend to just check before I access it to verify if it actually is going to do what I expect.
I tend to use the get method.
Which makes sense because it says it will... Weird, okay. I would have to double check the docs on it. But I want to say it returns none. I could be wrong on that. I'm actually trying to find the docs right now on it. Yeah.
Let me see if I have Python installed on this PC. Let me just quickly run.
I would do the same, but I am currently booted into an operating system that has no DevTools installed. Interesting.
I get a key error.
Yep, that is
So I
correct.
get an exception.
Yeah, after reading the docs, it throws a key error. If you were to do so in a language like JavaScript, which is I guess what my brain was immediately thinking of on this, then it's not going to throw an exception on it. It's going to return the value undefined. But that's an implementation detail. Yeah, no, that makes complete sense. Very good question. I mean, I personally always just double check it with, I always just double check before I access it, just in case I'm wrong, in case it doesn't exist. But it's definitely very important to know the actual fact of what would happen if you were to access it in a way that you, and it was not set. So thank you, Star. So the question for anyone here, if I were to attempt to access a value which is not currently set, and I were to specifically use a function called .get, wow, I cannot type. I mean, I cannot write today. But if I were to use a function called get, it's interesting. So if I were to use a function called get here, what's going to happen is it's actually going to throw what is referred to as a key error. And for those who were in the workshop last week, key error would be a type of exception thrown in Python, and that, if it is not caught or handled, is going to cause your program to exit. It's going to cause it to crash. So you would need to have go for it.
No, it's if you do an index with the square brackets, it will throw a key error. Get allows you to pass a second argument that can be returned instead.
Thank you. My apologies. Okay, yes, if you were to do it with square brackets like this. Correct, sir? Yep, okay, cool. Well, I misspoke. My apologies. Okay, so yeah, if you were to attempt to access this and this value is not set, this is actually part of the reason that we are doing a check up here to see if it is actually set, because we specifically do not want to throw a exception. But in the event we were to attempt to access it in this way and it's not set, then we are going to get a key error and we are going to crash our program. Unless we, of course, went through and actually had code in place to catch it. Briefly touched upon the workshop last week, but yeah, that would be what's referred to as a exception, and exceptions need to be bought and handled, or they will crash your program. But yeah, a very good point on that, and also that would be why on these that we have the bits of code and the like to check to see if they're set, because if we access them and they're not set, then we will crash, and that is not what we want. I apologize for any misinformation or confusion during that. But yeah, thank you. All right. Do we have any other questions or comments on this? All right, well, I have nothing to add. So tomorrow, or possibly tonight, one of the two, I'm planning to upload the slides that were used here, as well as the worksheet. And yeah, that's all I got. Next week is going to be on general program organization and structure. And after that, well, yeah, I guess I'll just mention the next week and not get too far ahead of myself. But yeah, I guess have a good one, everyone. Take care.